All right, here we are again in section 3.4. This is video number 2, and I'm going to show you 3 parts to solving a linear inequality. So first, when we solve the linear inequality, we're going to write the inequality statement, we're going to include a graph, and we're going to write it in interval notation. So those are the 3 things that we practiced in the previous video. So here we go. Here's our first inequality, and you'll remember, those of you who watch my videos on chapter 2, remember how I always put in the dotted line at the equality symbol. Well, this time you'll see me putting in that dotted line at the inequality symbol. And we're going to solve pretty much the same way that we solved equations. I'm going to add 6 to both sides in order to get the variable x standing alone. And that one only took 1 step for me to solve it. So this is the inequality statement. All right, so you can see I've got that that comes about just in the process of solving the equation. Solving the inequality. All right, so now that I've got the inequality statement, let me show you a graph. So here's -5, 4, 3, 2, 1. There's a 0 right there. And I want to show you all the numbers that are greater than or equal to -5. So the numbers that are greater than -5 fall into this region here. You can see that they're going to extend all the way out to positive infinity. And so the question becomes, right back here, how do I identify that end point? Is it included or not included? And since it said greater than or equal to, I'm going to put a bracket there and turn it in the direction of the number. So I have the inequality statement. I have here the graph on the number line. And the third thing I want to show you is the interval notation. Oops, sorry, that's not right. It doesn't go to 0. It goes all the way out to positive infinity. And remember, with infinity, we always use parentheses. So this is the interval notation. All right, so there we have our 3 components: the inequality statement, the graph on the number line, and the interval notation. Let's try another one. Here's my dotted line, because there's the inequality. I'm going to begin by subtracting 11 from both sides of the inequality. So there is the inequality statement. Now I'm going to do a graph. So let's say this is 4, 3, 2, 1. This is 0. I want to show you all the numbers that are less than 4. Notice that that x is on the small side and the 4 is on the big side. This is going to go all the way down to negative infinity. And since this does not contain an equals, I'm going to use the parentheses. So this is my graph. And finally, remember how interval notation resembles the graph. And we use the parentheses when we use infinity. All right, last one for this video. Here's the inequality symbol. So that separates left side from right side. I only need to subtract 4 here to have this inequality solved. So there is the inequality statement. Here, let's say this is -3. I want to show you all the numbers less than -3. So that takes me down in this direction. I'm going down to negative infinity. And we make a decision about how it's going to look. How am I going to close off this end here, and because it says or equal to, I'm going to use a bracket here. So this is my graph of the answer. And you can see, you remember we said at the beginning for an equation you get one answer, a linear equation you get one answer. For a linear inequality you get a whole range of answers. You get infinitely many answers. So when I put this in my final interval form, I'm just going to match what I see on the number line, and now I have my answer written in all three forms: interval notation, graph, and inequality statement.